Hello there and welcome back to another video. In today's video, I've got something pretty special that I don't get to do very often due to how expensive it is. Today, I'm going to be upgrading my personal NAS. This is my DIY NAS that I use for all of my backups, photo storage, and of course, storage of all of my YouTube videos and their raw footage. This NAS has already been through a couple of iterations, starting out as a basic Optiplex 7010 mini tower system that I shoved 3 4TB hard drives and a 2.5 gigabit networking card into, and then later, I added 10 gigabit networking to it, and shortly after that, I transferred the whole system into this 2U rack mount case and added 3 more 4TB hard drives with the help of an LSI HBA for a total of 24 terabytes of raw storage, which equated to 20 terabytes of usable storage after RAID 5's parity space requirements. This setup has run exceptionally for me for the past 2.5 years in this state, and frankly, I don't have any major complaints about it, except I do have one major issue with it that's cropped up recently. I'm running out of space. Recently, I peaked out at around 90% utilization of my 20 terabyte RAID 5 array, and I really don't have stuff that I'm willing to delete right now. I have been working through my old videos and transcoding their footage to a much smaller file size while still keeping decent quality, and while this has helped majorly, it's not enough, and I will run into that 20 terabyte ceiling repeatedly in the not so far future, even if I just keep compressing my old footage. So it's time to upgrade. So, sounds great. Looks like today I'll be throwing in some more 4TB NAS drives and expanding my RAID array, right? Actually, not so fast, because in my last video on upgrading my NAS, I said this. Next time I upgrade, it's gonna have to be a full storage overhaul with new, larger drives. And that's because I used all of the drive bays in this case. And to say that right now is a bad time to have to buy a bunch of new, high-capacity hard drives would be an understatement. For anyone unaware, the same crisis that has hit RAM prices and SSD prices has also hit high-capacity hard drive prices, and price per terabyte is extremely high right now. So what am I gonna do? Am I gonna have to shill out like $3 grand on a bunch of new hard drives? Well, thankfully for me, no. And that's thanks to today's video sponsor. Just kidding, I'm not famous enough to be sponsored by any hard drive dealer, especially in this economy. What I actually did was camp eBay for literal months with healthy cash reserves, waiting for the right storage deal to show up, and it did, in the form of these Oracle Sun branded Western Digital 14 terabyte data center grade hard drives. I managed to snag these drives for the sweet price of $192 per drive, which equates to $13.7 per terabyte, a pretty exceptional price in today's market. Now these drives are used. They're not new, recertified, or anything like that, but they are name brand drives from a well-rated seller, and they aren't that old. Plus, because they're data center SAS drives, they should still have plenty of life in them, especially for a home NAS that's not going to be hit anywhere near as hard as the database servers that these drives almost certainly came from. Remember, they're Oracle drives, and databases is what Oracle does and is probably what these were used for. In any case, when I came across the listing for these drives, I purchased 7 of them at $192 a drive, which after taxes equated to almost $1,500 on these hard drives. But for 98 terabytes of raw storage, that's pretty good, especially considering that a recertified Western Digital Ultrastar DC HC530, which is what these drives are underneath that Oracle Sun rebadge, goes for $330 or $23.50 per terabyte. In any case, alongside these drives, I'll be installing a new HBA as well. I ended up buying this because I made a mistake when researching if these 12 gigabit per second SAS3 drives would work with the 6 gigabit per second SAS2 controller that I already have, and I thought for a while that they wouldn't. Hence leading me to buy this LSI 9300-8i SAS3 HBA. I later realized that I was wrong and this purchase was unnecessary, but it wasn't that expensive, and I wasn't about to eBay return this card over $40 when I've already spent $1,500, so I guess I'm just going to be upgrading my HBA today as well. So let's get into tearing apart the old NAS. I'm going to be removing all of the hard drive cages and unmounting my 2.5-inch boot SSD. This will free up a 7th 3.5-inch slot, and I can just jam the SSD in some crevice in the case, as unlike a spinning drive, it doesn't really care about how well it's mounted. I also pulled the old HBA out of this system at the same time. Next up, I started pulling the drives out of the mounting cages while making sure to still be careful with them because they're actually currently worth more secondhand than I paid for them when I bought them brand new. Oh, and they also still have all of my precious data on them that I'm going to have to transfer to the new NAS later in the video. Of course, these don't hold my only copy of this data, but definitely the copy of this data that will be the least cumbersome to transfer to the new NAS. And so if I can keep that intact, I will. But with all those drives removed, I mounted the 7 new 14TB drives into the 3 drive cages. 2 cages got 2 drives and 1 cage got 3. And for anyone who's wondering, the reason that I can't use the bottom drive bay on 2 of the 3 drive cages is because I have a micro ATX motherboard installed in this case, and there will be no clearance between the motherboard and the SAS plugs for those bottom drives. I can only use those bays and have sufficient clearance if I'm running a mini ITX board, which I also can't do because that won't have enough PCIe expansion for my HBA and 10GB NIC. Alright, now that all of those drives are in the cages, I can move on to the final thing I have to do before I start installing everything back into the rack mount case. And that is cloning the Open Media Vault image off of the SATA boot SSD and putting it onto a different NVMe SSD. I'm doing this because of my data transfer plan for moving into the new NAS, which has to happen because even though I'm calling this a new NAS, it's not really a new NAS in the sense that it's not a whole new case, power supply, platform, set of drives and all. What that means is that I can't just leave the old NAS intact and once the new one is built, spin them both up side by side and transfer from one to another. Instead, I am having to decommission the old NAS in order to build the new one. So my plan is to use a random desktop computer to temporarily spin up the old NAS's OS image and data hard drives so that I can transfer the data to the new setup. This is why I need to copy the old OS to a drive that I can use in my temporary old NAS, especially because I'm going to be reusing the 2.5-inch boot drive in the updated NAS for the new true NAS installation. Hopefully that explanation made sense, and if it doesn't yet, I'm sure it will later in the video when I actually start doing what I'm trying to explain here. Either way, I've got my old OS image saved to a new SSD, so I can reinstall the old drive in the NAS, and feel free to wipe it and install TrueNAS on it. And speaking of installing, that's exactly what I started doing now. I mounted all of the stuffed drive cages and got my 40mm Noctua fan zip tied to the new HBA, which allowed me to mount that into the PCIe slot and start wiring everything up. This fan was really important to get on though, because something that I find very interesting with these HBA cards is that they run obscenely hot. Yes, they are designed to be in a server chassis with forced airflow over the heat sinks, but even 10GB NICs that are designed in the same way get nowhere near as hot as these cards. Frankly, I wouldn't be comfortable running one of these cards without a fan strapped to it. If I was running one without a fan, I really wouldn't expect it to last more than a couple of weeks before frying itself. After everything was plugged in and cable managed as well as I could, it's hard in these cases, give me a break, I powered on the system and have to say that I was extremely relieved to see all 7 drives show up on the HBA on boot. The SSD is plugged into the motherboard instead of the HBA, so not seeing it here makes complete sense. Next up, I grabbed a TrueNAS Scale installation USB and worked through the installer with 0 issues. Once the OS was installed, I was able to access it from a browser at the same IP that the old NAS used, due to the DHCP reservation that I have set for the MAC address of the NIC, which of course didn't change during this upgrade. After quickly double checking that nothing seemed too majorly off in TrueNAS, I pushed forward with closing up the NAS and mounting it back in the rack off camera, as I wanted my desk clear for what was coming next. Plus, I also wanted to be able to easily hook the NAS up to the rest of my network infrastructure, including the 10GB/s link that goes to my main desktop, which works just fine as well. After racking up my overhauled NAS, I was straight back into TrueNAS to get my configuration dialed and my pool built. But sadly, TrueNAS wasn't happy with my hard drives. TrueNAS said that all 7 of my hard drives were formatted with Data Integrity Feature, or DIF, and therefore it wouldn't be able to use them to create any ZFS pools. From what I understand, this means that these drives are formatted with different size sectors, something like 520 bytes instead of a more normal 512. Running the command on screen should allow me to reformat all of my drives with a 512 byte sector size. And so I used tmux in TrueNAS to execute this command on all 7 drives simultaneously. This took a very long time to complete, roughly 18 hours in total. But when I came back, TrueNAS wasn't throwing any more errors about DIF, and it looked like my drives would work just fine in a pool now. Except they weren't reporting the correct capacity. They were reporting in at slightly less than 14 terabytes apiece, and before you say that this is a terabyte to tebibyte conversion issue, it's not. This isn't a result of drive manufacturers marketing their drives in terabytes, where 1000 gigabytes is 1 terabyte, and OSs reading the drives in tebibytes, where 1024 gigabytes is 1 tebibyte. This will cause the OS's readout to look slightly lower than what the drive says it is, and it's the reason that your 1 terabyte SSD in your desktop computer always shows up as 932 gigabytes. But that wasn't the issue this time. The reported capacity of the drives in terabytes was 13.72, equating to a little over 12.5 tebibytes. I should be seeing 14 terabytes on the dot and a little over 12.7 tebibytes per drive. So I am missing space. Some research showed me that this was likely a result of my formatted size of 512 bytes per sector not aligning with the physical sectors on the drive, causing some of the sectors on the disk to go unused, hence costing me space. Fortunately for me, as this was all new territory for me and honestly still is, so I was getting a little worried, I found a Reddit post from someone who had the exact same Oracle Sun 14 terabyte drives as me, who had run the exact same format as me previously on their drives, who had the exact same issue as me, and who, to the T, had the exact same amount of capacity lost per drive and the exact same number of sectors formatted per drive as me, and who had found a solution. Finding this post was one of the most exceptional feelings ever, because I think everyone in this space knows that you generally don't find exactly what you need this easily. But for me, I managed to find this, and took their command, which was basically the same thing that I did before, but with a 4096 byte block size instead of 512, and I added the FFmpt equals 1 argument to it that I had picked up from a previous forum to hopefully speed it up. And then I ran that on all of the drives. Adding FFmpt equals 1 made the format take like 20 seconds per drive instead of 18 hours, and after executing this format on all drives, I went through with sgreadcap and was relieved to see a perfect 14.00 terabytes per drive, and that number translated into the TrueNAS UI as well. The chain of commands that I used on these drives to get them functional is on screen right now. I'm not sure if you could just jump to the second command with the FFmpt equals 1 argument from the start and get your drives ready to go in about 20 seconds per drive, and I sadly can't test that because I don't have any more of these drives in their original state, but just know that this is how I did it on these drives if you're in a similar situation. After that kerfuffle was over, I built my pool with all 7 drives and chose to run it in RAID Z2. I chose RAID Z2 because I want more redundancy with this pool than just a single drive, and that's for a couple of reasons. First, with larger drives in general, you usually want more than 1 drive worth of redundancy. This is because if one of the drive fails in a pool, the resilvering process can take a very long time to complete, and a second drive failing before the resilver completes is far from unheard of. Then, my second reason for wanting 2 drives of redundancy is that these are used drives, not recerts or new drives. I checked their smart data, and all of these drives have roughly 47,000 power on hours on them. Not necessarily end of life yet for a data center SAS drive, but not brand new by any means. Thankfully, all of these drives do seem in very good condition regardless of their power on hours though, as they have very few spin up, spin down cycles and load unload cycles on them. And none of the disks have any sector issues. Either way, I'm not settling for anything less than 2 drives worth of redundancy, so RAID Z2, here I come. After making the pool, I had roughly 65 terabytes of usable space after parity and padding was considered, which is a huge uplift from my previous 20 terabytes of usable space. I then started to build my datasets, users, shares, and privileges, and I won't go into much detail about that here because I'm not doing anything interesting, just a few users and a few private folders with 1 shared folder that all users can access. But what I will move on to now is the process that I followed to transfer data from the old NAS to the new NAS. To do this, I used my Dell Precision 3630 computer and threw the SSD that I had cloned my OMV installation onto earlier into it. I then added the LSI 9207-8i HBA that I pulled out of the NAS and used that to get all of the drives connected to the system. This computer doesn't have enough drive bays for all these drives, and sadly 2 of the drive bays in my 3630 only have the dual 2.5-inch caddies in them, so I had to get a bit creative with getting things connected. And I think you can probably see why I wanted the desk space back for this step. Finally, I threw in one of my 10 gigabit per second networking cards for fast file transfers. After plugging everything in, I booted up the system and it couldn't find the OS image. I tried all of the basic things with Secure Boot, Legacy, and UEFI, but it just refused to find the image. Thankfully, I had kind of expected something like this could go down, and it wasn't too off-putting. Remember, as I said in passing earlier, I do have a full backup of all of this data on some other hard drives that I made sure to take in case this method didn't work at all, and in case I somehow break my RAID array that these 6 drives make up currently and lose my data in that way. The nice thing about this RAID array though, is that it's just created via Linux MDADM, and so if I reinstall OMV from scratch, I should be able to see it show up and mount it like nothing ever happened. So I did just that. Now, I had so many issues with getting OMV installed and working on this system, including my ISO being so old that the repositories it tried to update from didn't exist anymore, the 10 gigabit per second networking card causing all sorts of issues, and much more. But to cut to the chase, as this video is already quite long, I ended up with an install of OpenMedia Vault 7, which is a newer version than version 6 that I had been running. I also ended up using a USB 2.5 gigabit per second Ethernet adapter because the 10 gigabit per second card refused to work, which I found really weird because this card has not given me problems in the old OMV NAS or the new TrueNAS NAS, but whatever. And somewhat surprisingly to me, the easiest part of the whole process was mounting the old RAID 5 array and file system, recreating the shares, and then being able to copy directly over from the shares on the Frankenstein NAS to the new shares on the updated NAS. After about 1 day of transferring files, everything was up to date, and I shut down the Frankenstein setup. However, I will not be wiping the drives from this NAS until I'm sure that the new NAS is all set, which means they'll probably be sitting as a backup for a couple of weeks. After that, I may resell these drives while I can get good prices for them just to try and offset the cost of the new drives some, as those were really quite expensive even though I got a good deal on them. Now, my final note before I finish the video is going to be on the performance of this new NAS, because I got gains in this aspect that I wasn't expecting at all. In particular, when copying files off of my editing SSD to the NAS, I noticed that instead of my previous maximum write performance of about 180 megabytes per second on the old NAS, I was now able to sustain 700 to 800 for the duration of a 325 gigabyte transfer. And at times throughout the transfer, I hit almost a gigabyte per second. All of the RAID Z2 calculators that I had looked at showed me that I should only expect the write performance of a single drive with my new array, which was going to be higher than my previous array because my old drives were both pretty full and 5400 RPM drives instead of 7200 RPM ones. But clearly my workload gets handled differently by ZFS, and that allows me to get much more performance out of my array, which is not something I'm going to be complaining about anytime soon. Moving on to read speeds, the new array's read speeds were roughly the same as its write speeds, that being 700 to 800 megabytes per second sustained over long transfers. And all of the dips that I saw seemed to be due to the SSD that I was copying to struggling with the sustained write load. So I have to be honest, I'm super impressed with that performance and I'm super happy to have it now. This will make putting footage onto my NAS so much faster and copying over old video files to reference in new videos, like I did earlier in this video, so much quicker. Needless to say, I'm really stoked about how this came out and can't wait to use this NAS more. Well, that's all that I have for you in today's video. I hope that you were able to at least enjoy it and maybe even learn a thing or two. In any case, I hope to see you next time. Goodbye.